Today, we will understand two very important concepts of motion: distance and displacement. When an object moves from one position to another, we need to describe how much it has moved. Distance is the total length of the actual path traveled by an object. This glowing line shows that full path. For example, if a student walks 5 meters, the distance traveled is 5 meters. Distance tells us how much path was covered. It does not tell us the direction. So distance is just magnitude. Therefore, distance is a scalar quantity because it has magnitude but no direction. What is displacement? Displacement is the straight line change in position from the starting point to the final point. Unlike distance, displacement also tells us the direction of motion. It bridges the gap between where you started and where you are. Because displacement has both magnitude and direction, it is a vector quantity. It is a vector quantity. It is a vector quantity. Distance follows the actual path, while displacement is the shortest straight line change in position. Now you know the difference. Let's explore straight motion. If a car moves 20 meters straight forward, its distance and displacement both have a magnitude of 20 meters. Now imagine a student walking 10 meters east and then 10 meters north. And then 10 meters north. The total distance is the complete path, 10 plus 10, which equals 20 meters. But displacement is the straight line distance from the starting point to the final point. Let's calculate the displacement. Using Pythagoras' theorem, the displacement is the square root of 10 squared plus 10 squared. So the displacement is approximately 14.14 meters in the direction from the starting point to the final point. Now consider a person who walks from home to a park and then returns to the same home. The distance is not zero because the person actually traveled a total path of 200 meters. But the final position is the same as the starting position, so the displacement is zero. Remember, distance is the actual path and a scalar quantity. Displacement is the straight line change in position and a vector quantity. Distance represents the length of a traveled path, so its value cannot be negative. Displacement can be positive, negative, or zero. This depends on the chosen direction and final position. Here you can clearly see that the traveled path gives distance, while the straight line change gives displacement. For the same starting and final positions, distance is always greater than or equal to the magnitude of displacement. Displacement can be positive, negative, or zero, depending on the chosen direction and final position. Here you can clearly see that the traveled path gives distance, while the straight line change gives displacement. For the same starting and final positions, distance is always greater than or equal to the magnitude of displacement. In real life, you may walk along roads and corridors, but displacement only considers your starting and final positions. A common mistake is to use the total path as displacement. Remember, displacement uses the straight line change in position. Distance is scalar and follows the actual path. Displacement is vector and connects the initial and final positions. A student walks 50 meters east and then 50 meters west. What is the displacement? Exam tip: if an object returns to its starting point, its displacement is always 0. Distance is the total path traveled, scalar. Distance is scalar, while displacement is vector. Displacement is the change in position. Now you know the difference between distance and displacement. Understand the concept, and you can solve the questions with confidence.